We're going to talk about graphing exponential functions, which kind of look like quadratics. So they have that kind of U-like shape, but really it's going to level out as it gets close to the zero. So the way that we do these is we can set up a table, and then if you want to check it using Desmos, you can. So we're going to do an X, Y chart. And we're going to pick 3 numbers to plug in. I always tell people to pick 0, 1, and 2, because if you've ever heard of the expression of something growing exponentially, it grows really, really quickly, really, really fast. So using smaller numbers is going to be way better for us. So we're going to take our 3 inputs, 0, 1, and 2, and we're going to plug them in for X to solve for Y. So 2 times 2 to the 0. You can do this using PEMDAS, or you can type this whole thing in your calculator. So if you're doing PEMDAS, anything to the 0 is just 1. So 2 times 1 is 2. That's our very first output. I like to encourage people, if you are doing this in your calculator, just make sure if you ever plug in a negative number to be really careful. And also just putting this all at once in your calculator should work. But if you need, make sure you're using that little roof key before you hit your exponent. We're going to plug in our next input of 1, which is 2 times 2 to the 1. You can put that whole thing in your calculator, or you can do 2 to the first. Anything to the first is itself. So 2 would be 2 times 2 is 4, would be our output. Since 2 to the first is 2. The last input is to the second power. So we're going to take our 2 and plug it in for X. If we follow PEMDAS, we'll do 2 squared, which is 4. So 2 times 4 is 8. Go ahead and separate those out so you can see my work step by step. And once you have your numbers in your table, you just plot it, connect it, and you're done. So our first point is 0, 2. So we'll start at the origin or the 0, and we'll go up 2 and put our first dot. Our second point is 1, 4. So we'll go over 1 and up 4. Our last point is 2, 8. So we'll go over the 2 on the x-axis and up to the 8. You'll notice this is already growing really, really, really quickly. So we'll connect and we'll shoot that graph up that way. And then we're going to swoop it down towards the 0 line right here. And it's going to just ride the wave of that 0 line. It's going to get really, really close, but it's never going to touch. Kind of like those asymptotes we talked about in our other graphs, graphing polynomial functions. Sometimes you have fractions, so I like to let people know if they want to go ahead and make that a decimal. 1/4 is 1 divided by 4 in your calculator, which is 0.25, and you are more than welcome to do that. You could also pick numbers that are divisible by 4 if that's easier for you. I think for the sake of consistency, I'm going to use 0, 1, and 2, and then I'll just make that a decimal to make it easier, knowing that these grow really quick. So for our first input, we'll have the 0.25 times 6 to the 0. Anything to the 0 is just 1. So we'll have 0.5 times 1, which is 0.25 times 1, which is just 0.25, which means that if we're plotting this, we go right at the 0 and we go up a quarter of a box. So it's really, really, really close to the origin. 0.25 times 6 to the 1, you can put that in a calculator. And I'm not looking for the graph to be perfect. 6 to the first is 6. And then if we're doing a quarter of 6, if you think of a half of 6 is 3, that means a quarter of 6 is 1.5. But your calculator could also do that for you. So we're going to go over 1 and then up a box and a half. Separate out our steps. And then 0.25 times 6 to the 2. 6 to the second is 36. 6 times 6. And then a quarter of 36, if you don't know, is the same thing as doing 36 divided by 4. So that's 9. Your calculator would also tell you that. So you go over 2 and up 9. You can tell that this graph grows even quicker than the other one. And then just ride out that wave over towards the opposite direction. So we definitely see that swishing effect. In real life, exponential growth could be used to model maybe investments, maybe the growth of bacteria in a petri dish, stuff that grows really, really fast. So that's why we use those smaller numbers in the beginning. Sometimes I'll have a little extra number in front. Well, actually, no, that looks the same, but you might have a little extra number with the exponent. So we can talk about that for this one. We'll have our inputs again. The calculator can do this, but you'll want to use parentheses if you're using your calculator. So we're plugging in that 0 for x. So if you're using your calculator, you would type this in 5 times 2 with the little arrow, parentheses 0 minus 1. I'm going to use PEMDAS here. So I'm going to do 5 times 2, and then I'm going to do parentheses first. 0 minus 1 is -1. 2 to the -1, which if I was doing in my calculator, I would use parentheses, is 1/2. And or 0.5. And 5 times 1/2 is 2. I don't know why I put a decimal there at first. So it's a lot more work if you do PEMDAS, but if you do want to do this whole thing in your calculator, it would look like this. 5 times 2 to the 1 minus 1, since we're plugging in 1 next. 1 minus 1 is 0. So we'd have 2 to the 0, which is just 1. So if we plug in a 1, we get 5 times 1, which is 5. The table's a little bit messy today. That's okay. And then for our last input, I'm going to put that over here. 5 times 2. We're going to plug in a 2 for x minus 1. So we're using that original formula. 2 minus 1 is 1. So the new power of 2 is 1. Exponents before multiplication. So we'd have 5 times 2, which is 10. Once again, you could do this in your calculator. Just make sure you use those parentheses before you hit that arrow key. That's probably the most critical step that some people miss. We'll put it on our graph. So for our graph, we'll go to the center at the 0 and we'll go up 2. We'll go to the 1 and we'll go up 5. And we'll go to the 2 on the x-axis and go up to the 10 on the y. Connect them on a bit of a curve. Notice it growing really, really fast. And then swoop it so it's riding that wave coming towards 0. And that one was just a little bit more work if you are doing PEMDAS. I could see that being a little bit more frustrating if you make a mistake. So please feel free to use the calculator with the parentheses on that if you'd like to. We'll do one last graph just to make sure that we feel comfortable on it. Setting up our XY table. And you could probably tell these grow really, really fast, but if you do want to use negative numbers and give yourself a little extra challenge, or you want to use bigger numbers in your table and just know that you might have to do your best to connect with 2 points, you're more than welcome to. So we're going to plug these numbers into x. So we'll have 2 times 2 to the 0, and this time the -1 is off the side. So if you do this in your calculator, it would look like this. 2 times 2 to the 0, and then -1. So you wouldn't need parentheses there because it's going to know to do exponents first. If we're doing PEMDAS, same thing. 2 to the 0 is 1. We'll do multiplication and then subtraction. So 2 times 1 is 2. 2 minus 1 is 1. Our first output is 1. I should probably write a tad smaller for this one. The next one, we have 2 times 2 to the 1 minus 1. 2 to the 1 is just 2. So it's 2 times 2, take away 1. 2 times 2 is 4, and 4 minus 1 is 3. So our next output is 3. For our last output, we're going to plug in a 2 for our input and see what we get. Once again, you can use your calculator, just no parentheses here. 2 squared is 4. 2 times 4 is 8. And 8 minus 1 is 7. So our last output is 7. So when we go to plot this, we'll start at the origin and go up 1. And if you start with 0, it's always going to start at that origin. We'll go over 1 on the x-axis and up 3 on the y, over 2 on the x and up 7 on the y. We'll connect and swoosh up, and then we'll ride this really close towards the x line there. So I did mention that you could use Desmos to check these if you wanted to. I am perfectly willing to show that if I can find my Desmos app. Yep, there it is. And we can check by typing in 2, just go a little bit closer, 2 times 2, and it's to the x power. So you'll hit that AB button and then your x. You'll notice it's already forming that curve. Now, if I put -1, it's going to automatically jump down to there. So I'd want to make sure that that 1 is bigger, and it does match my graph. If you zoom out a little bit, you might be able to see it a little closer. If you zoom in, hit the equation, the dots will also come up, and you can click on them, and you'll see your points. And they might be slightly different than yours, depending what they pick. So you can see they picked a negative, but they have the 0, 1. If you were using Desmos to check this first one, 2 times 2 to the x, let's make sure that works out. 2 times 2, hit the little button with the AB to the x, and that also looks really, really close to the graph. You can zoom it out to see. If you click on it, it comes up with the 0 and the 2. And not all boxes on Desmos are 1 for 1, so it might look like it's 0, 1, but if you click on it, it's actually 0, 2, so that's kind of helpful. If you have one with a fraction that you're trying to check in Desmos, making it that decimal first of 0.25 might be better. If you wanted to make it a fraction, we could hit actually 1 divided by 4, and that's really nice. It actually shows up as 1/4. I know it's a little bit tricky to see, so all the zooming out and zooming in might be giving you a little headache, but it kind of works. And then, ooh, that actually didn't work. So if we wanted it to be separate, you might want to stick with the fraction, but there might be a way to do it. Yeah, so see this little arrow under function, if you hit that over 1 to the right, then you can hit times 6 to the x, and you'll get your same graph, which is really steep. Click on it, the equation, the dot will come back up, and you'll see their first dot was also 0.25. So that's just a little way that you can check using the Desmos app, but in all honesty, these ones aren't as tricky as graphing polynomial functions without Desmos, so you should be able to do it without. And just let me know if you have any questions about plugging in our initial inputs and plotting on the graph.